24, 2003, Concorde made its final commercial flight, taking passengers, including various celebrities, from JFK Airport in New York to Heathrow in London. The iconic airliner had been in operation since the mid-1970s and was famously capable of achieving more than twice the speed of sound. But ultimately, thanks to rising maintenance costs, high ticket prices, and a severely damaged reputation following the crash of Air France Flight 4590 in July 2000, the fleet was grounded and retired. Ever since then, supersonic flight has been reserved for military jets only. Various governments now have multiple models of fantastic flying machines that can cruise over whole oceans and seas within just a couple of hours, and comfortably faster than the speed of sound. Crucially though, more often than not, they can only travel over oceans and seas, because many national laws prohibit an aircraft generating a sonic boom over land. For example, in the United States, according to the Federal Aviation Administration, flight over land in excess of Mach 1, that is, in excess of the speed of sound, is not allowed by U.S. law unless specifically authorized by the FAA. A sonic boom is the 100-plus decibel crash that can be heard whenever a vehicle breaks through the sound barrier. It can sound like rapid thunder or an explosion. And while infrequent exposure isn't likely to cause lasting harm, it's thought that repetitive sonic booms may damage eardrums and cause deafness. A loud and powerful enough boom might also cause damage to weaker buildings and structures, while there's even some suggestion that the sonic sounds of high-speed travel could trigger heart attacks or seizures in some cases. It's a matter that's still widely debated by those within the aviation industry, lawmakers, and health professionals. But for now, in America and other countries, it boils down to the simple fact that you can't go supersonic over land, which is a major problem if we ever hope to travel faster. Enter the X-59. Commissioned by NASA and built by aerospace juggernauts Lockheed Martin, the X-59 is a plane like no other. It promises quiet supersonic technology in a vehicle that its creators hope will ultimately move at faster-than-sound speeds, but reduce the sonic boom down to something that's much more manageable. Whenever the X-59 is mentioned, NASA now refers to a much quieter-sounding sonic thump, suggesting that it will only ever produce a noise comparable to someone closing a car door from across the street. The goal is for an X-59 to one day zoom above our heads, unnoticed, to fade into the background, especially in urban areas. These are startling claims for a machine that truly looks as though it comes from the future. The X-59 is extremely long and thin, with around half of its length taken up by a seriously impressive nose cone. It's built to be as aerodynamically efficient as possible, but also to stretch out the sound waves around it. This is what will reduce the decibel levels of the sonic boom, now thump, that it creates, with designers aiming for something that's just 75 decibels or less on the ground. This calculation is how they come to their closing a car door comparison. In its current guise, no one is claiming that the X-59 will be a passenger jet, and that's because it has cockpit room for just one pilot and no one else. The cockpit itself is interesting though, because it's seamlessly embedded into the body of the plane, again to better the aerodynamics. But the trade-off here is that the pilot cannot view out of the front of their vehicle. They have no front-facing window, and so they're flying blind. Or at least they would be, were it not for the state-of-the-art technologies at their disposal. NASA has created an External Visibility System, or XVS, which uses multiple cameras from the top and bottom of the plane to channel a true real-time view of what's happening outside onto screens inside the cockpit. The pilot then navigates using these screens, while there's another camera beneath the pointed nose cone to guide the plane home during landing. What's more, the screens will also display all the important metrics the pilot needs to know, like speed and altitude, thereby condensing the traditional cockpit instrument panel into something that's much smoother and simpler. To the uninitiated, flying an X-59 looks a lot like playing a VR video game then, with all of your vital statistics in the corner of your view. But those statistics are also pretty mind-blowing. If all goes to plan, the X-59 will rush through the skies between Mach 1.42 and Mach 1.5. That's 1.5 times the speed of sound, and a top speed of around 990 miles per hour. And that's all happening at an altitude of 55,000 feet, comfortably higher than most passenger flights, and marginally higher than most military jets too. Lockheed Martin claims it will enable passengers to, quote, travel anywhere in the world in half the time it takes today. So what's next? Currently, the X-59 is undergoing various tests. It's already been subject to high-speed wind tunnel testing, wherein a 9.5% scale model of the jet is put through its paces at a NASA facility. The XVS has also been rigorously tested on the ground and on board different planes, with pilots trailing the real-time video feeds that will be so vital to this plane's success. In 2022, though, NASA will take the biggest and most important step when the finished X-59 is test-flown across America. These flights, which will continue until at least 2025, will assess performance and safety, as would happen with any other plane. But they will also serve as opportunities to collect crucial data and community feedback, because the success of the X-59 ultimately rests on whether it really can turn the boom into a bump, whether it really can reduce the impact of breaking the sound barrier down to 75 decibels or less. If it does that, and if it can satisfy aviation regulators that supersonic travel over land is possible, then we will have entered a new phase in the long and storied history of flight. From that point forward, there will likely be a rush to work out how to convert the X-59 breakthrough into something that works for a commercial passenger vehicle too. The distinct X-59 design could become the standard for airplanes in the future, or something at least similar to it. Clearly, changes will have to be made. And somehow we'd need to combine the sonic boom-reducing aspects of it with a cabin that could hold tens, maybe even hundreds of people. Nevertheless, NASA, Lockheed Martin, and most other aviation and aerospace firms know that the clamor is there for consumers who always want to travel faster. Of course, in the meantime, this cutting-edge NASA machine could have a major impact on the military jets of the future, too. At present, we already have military planes that can travel faster than the X-59 and at a higher altitude, but there's been no cloaking the sonic boom until now. Were a supersonic military jet to pass above you, then you'd certainly know all about it. But perhaps in the future, they'll be a little less conspicuous, and perhaps more will be shaped as per the slender, sound wave silencing design of the X-59. If you had a chance to fly in one of these, would you do so? Where would you go? And how long would you expect the flight to take? How would you feel knowing that your pilot couldn't actually see what was in front of them and was operating the plane via video feed only? What's clear is that this incredible plane could usher in a once-in-a-generation change to the aviation industry. And just as Concorde forced travelers to rethink what was possible in the latter decades of the 20th century, the X-59 could have us dreaming of far-off lands in double-quick time by the middle of the 21st. And that's why NASA is building a quiet boom supersonic